So first thing we're going to do is talk about sort of trigonometry. Now, as you probably know, trigonometry is the study of triangles. So it's not restricted to sine, cos, or tan, which is what most people think about. So anything that relates to the study of triangles, including their angles, of which there are 3, including their sides, which of course there are 3, is to do with trigonometry. Or you'll sort of split with regards to sort of equilateral, isosceles, scaling, referring to sides, whether you've got, you know, acute angled, right angled, obtuse angled, or to do with angles. They all relate to sort of classification of triangles, and that would still be trigonometry. And obviously, in previous results, you know that you've got right angled triangles, which allows you to apply Pythagoras' theorem. Technically, that would also be trigonometry.
Yep.
And that's your c squared equals a squared plus b squared. And other things like just your angle sum of 180 degrees is also trigonometry. Nothing new there, hopefully. And in year 9, you probably would have come across sine, cosine, and tangent of theta. You would have probably learnt the term SOHCAHTOA. And it's important to recognize that things here refer to right angle triangles only. And so if you have a right angle triangle, then the longer side is called the hypotenuse, which would also importantly be the angle that is the side opposite the right angle.
Yeah.
Now you will need to actually pick an angle, in my example theta there, and then the opposite side to that angle would be called the opposite side, and the one next to that angle is called the adjacent. And of course, that really depends on which angle you picked, because if I picked alpha, then this would be called the opposite, and this would be called the adjacent. Regardless of which one you pick, sine is defined to be opposite over hypotenuse, cosine is defined to be adjacent over hypotenuse, and tangent is defined to be opposite over adjacent. In year 9. These are actually not so-called trigonometry. I mean, it's part of trigonometry, but it's part of really what's called trigonometric ratios, because after all, these are all ratios.
Yes.
So for your trigonometric ratios, sine, cosine, and tangent, they're ultimately trigonometric ratios. You can think of them as ratios between sides of the side lengths of right angle triangles, the sides of right angle triangles. Because the hypotenuse is the longer side, that tells you sine is less than 1, cosine, well, would also be less than 1, and tangent you've learned as that. And you don't really know anything particular about that, but recognize you're always taking sine, cosine, or tangent of an angle. But the whole thing represents a number, which is a ratio. So for example, sine 30 is just another fancy way of writing a half. None of that should provide any confusion, and hopefully you're clear with that. Now, of course, our definition so far talks about right angle triangles. So the question now is, what if I want to work out sine of 100 degrees? Now, if you use our definition so far, you go ahead and dutifully construct a right angle triangle. You go, here's my angle of 100 degrees. You draw it out. And where's my triangle?
Wait a second. Wait, is that an accident that your line went in the wrong direction?
Well,
oh,
think about it.
Yeah, where is your
right?
triangle?
You know, 100 degrees, it's got to go that way, right?
Maybe we should convert it to another quadrant.
So all right, so I can't make, you know, a 100-degree right angle triangle, right? So then people might just go, okay, you know what, let's just doesn't mean I can't make a 100-degree angled triangle. I mean, I could, right?
But then there just won't be right angles in it.
And so, okay, if this is my angle and I want to take sine of 100, all right, which side is opposite?
The side at the bottom.
So if we call this opposite, which it would be when we talk about triangles in general, then which one's the hypotenuse?
If that is the opposite, then I think the one on the left.
Why do you say the one on the left? Why isn't the one on the right?
Because if that's the opposite, then yes, it is the one on the right.
How do you know it's the one on the right and not the one on the left?
Because I thought about it like in a way of the right angle triangle that you just drew, and I matched all the sides.
Well, you would be wrong. And essentially what I'm saying is there is no hypotenuse. Because remember, the hypotenuse is the side opposite the right angle, or the longer side in a right angle triangle. You don't have a right angle triangle. You don't have a right angle triangle.
Oh, that is amazing. Okay, yeah.
I mean, if this is 100, we've got an alpha, we've got a beta, right? And they must add up to 80. It's not possible one of them's 90. If you have a right angle and 100, then you can't make a triangle.
Okay, there is no hypotenuse. We have two
So
adjacents.
in other words, these definitions don't make any sense.
Yes. But I mean, if you know like the size of one of the other angles, then you can use the sine rule and you can figure it out.
But the sine rule would still need to work out a sine of what you could. And I guess you're kind of, perfect cue, because I was like, obviously you've got the sine rule, cosine rule, and area of a triangle. And yeah, maybe, if I know the sides, I would, but the thing is, I need to get a value for sine of 100, right?
Yeah.
So what does sine of 100 mean? I mean, you can use the sine rule, but I mean, at some point you're going to need to work out what sine of 100 is. And what does that number mean?
I mean, if sine using the ratio is opposite of a hypotenuse, and we've just established that hypotenuse doesn't exist.
Therefore, how does it mean anything, right?
Well, we know that what sine of 30 is, so maybe we can figure out what sine of 180 and then subtract it by sine of 30.
But why, right? I mean, you just got told that. So, sine of 100 is equal to sine of 80, and it's true, and your calculator will confirm it. But if you don't know what sine of 100 means, how can you say it's true? Right?
Yes.
So the point is, these definitions are not going to work outside of right angled triangles, which is why that caveat was all the way back here, right angled triangles only.
Sokotowa. Yeah.
And this was not even really the real definition. This was just the simplified definition. And therefore, to get to angles of any size, we now need to go to, the real definition.
Yes.
So-called the real definition, if you like. And I think you've done this before, so I'll go through it quite quickly, is you have a Cartesian plane. Nothing ordinary.
All stations to central.
And we will draw a circle. Center origin, radius r. Now, do you agree that I've got a circle, center origin, there's nothing, strange or, I mean, I'm perfectly entitled to do that, right?
Yeah.
And I'm also perfectly entitled to just draw a ray from the center of the circle out at some angle, right?
Sure.
And I'm just going to call that ray. I'm going to call the angle that ray makes with the horizontal to the right, theta. Now, you agree that, I just randomly drew a ray. It could not, it might be here, but I could change theta to be bigger or smaller, depending. It could go here, it could go here. Doesn't really matter what value theta is. I could draw a ray, right? If I draw a ray, will it hit the circle?
Yes, it will.
Right. So I'm just going to call that point that it intersects the circle P. And this P will have some x coordinate and y coordinate. Does that make sense?
Yes.
And so now I'm just going to define sine of theta as the y coordinate of P divided by R. And similarly, I'm going to have a definition of cosine and tan by x over R and y over x.
Oh, I see it. Yeah.
So now, will I always have an x and a y for every value of theta?
Pardon?
If I change theta to any value I want, will I have a point P?
Definitely.
Will I have a x and y coordinate?
Definitely.
Will I therefore have a sine, cosine, and tangent of that so-called angle?
Yes, you will.
Yeah. And we actually also define the reciprocals. So these are reciprocal ones, which I think you may have done by now. And so this is
the cosec.
so they're just defined to be the reciprocals.
Cot. Yeah.
And so now, just the x coordinate must be between r and minus r, right?
Mm-hmm.
So we also know that sine theta must always be between less than or equal to 1 and greater than or equal to minus 1. And cosine theta must always be between 1 and minus 1.
So the circle cannot be larger?
Well, the circle could be larger, but so would x.
Yes, get it. Mm-hmm.
So, x can't be larger than r, right?
No. Mm-hmm.
No matter which point you pick, the x coordinate can't be like somewhere out here.
Yes, I understand now.
Right. Okay. And, there is a, mnemonic that you've already quoted, which is, all stations to central. Some people use add sugar to coffee, or, all stations to Chatswood. Doesn't really matter. And as you know, that this represents all of them are positive. This represents sine being positive. And obviously it's reciprocal as well. This represents tan, and therefore it's reciprocal being positive. And this represents cosine being positive, and so on. Now that is true, but do you understand why that's the case?
I think I do.
Why?
Because now we know that, for example, the sine is y over r, and in quadrant 1 and quadrant 2, the y would be positive. But then, however, if you flip the triangle over the quadrants, the y is now negative, and the fraction would be negative. So sine, consequentially, will also be negative.
Yeah, basically just consider the the polarity of x and y. So in this case, both x and y are positive, and so obviously well, r is always positive, obviously. So that will be positive, that will be positive, that will be positive. In this case, x is negative, y is positive. So well, that will be positive over positive. That will be negative over positive, and that will be positive over negative, and so on.
Yeah.
And that's why you get those situations, right?
I get it.
And, it would also give you your identities. So we know that sine squared theta plus cos squared theta equals 1. And you can kind of prove it by using the definition and using the sort of Pythagoras' theorem. We've got 1 plus tan squared theta equals sec squared. You've got 1 plus cos squared theta equals cosec squared. You've got the fact that, tan theta equals sine theta over cos theta. You've got the fact that cos theta equals cos theta over sine theta. And, all your related angles, which I'm not planning to go through right now because we want to prove the sort of compound angle. But this is just a quick revision of everything that you hopefully should be familiar with at this point.
Yeah.
Good. All right. So we're going to now keep all this in mind. And our question now is, how well, there's a bit of a spoiler alert, but basically we will aim to examine, I already told you at the start of the lesson, so I guess it's not too much of a spoiler, but usually it's designed, I normally wouldn't have told you beforehand. So we'll aim to examine cosine of alpha minus beta, all right?
Yeah.
And we will kind of use the definitions to do that.
Okay.